Hi, Becky Peltz here. I like working with Python Jupyter Notebooks. It's a good tool for testing and documenting code concepts. Experimentation is one of the fun parts of writing software. In this video, I'm going to use a Jupyter Notebook to share the meaning and importance of data immutability. Let's talk about data mutability and immutability in programming. Mutability basically means change, the ability to change. So if we have a data structure that allows us to change data throughout the course of our program, that's mutable. There are immutable data structures where you can't change it. Once the data is set, it's set for good. Why do we care about immutability and mutability in our programs? Well, it's going to give us more consistency if we have immutable data. It's going to be easier to debug if the data is immutable. And we can prevent something called side effects with immutable data. So let's look at two data structures in Python, list and tuples. Lists are mutable and tuples are immutable. Let's look at a Jupyter notebook with some Python code along with some documentation. So first of all, if you're refreshing yourself on lists and tuples or you're new to them, lists contain lists of data and tuples also contain lists of data. Both are indexed, and this means that I can access any given piece of data by its numeric value in a list. So starting at 0, list 0 gives me the first piece of data in either a list or a tuple. Immutable data is data that cannot be changed once set. And we're going to see that tuples are immutable, whereas lists are mutable. So what we're going to demonstrate in the end is what is a side effect. What we're going to see is that lists can have side effects, and that's due to the mutability of the data. So let's take a look at a list. And we've got some code here. We're going to create a variable a underscore list, and we're going to set it equal to 1a 3.51. So we're able to add data of different types to the list. We then can access each item in the list by its index. So we're going to see that a list 1 can be accessed using the 0 index. So we're going to just print the a list so we can get a look at it. And then we're going to append a new value to the list, hello. And then we're going to modify the second element, which is accessed with a list 1, to crunch. So we'll change a to crunch and add hello. That changing of a to crunch is mutability. Then we can print the list after that, and we'll also look at accessing 0 and 3 from the list. So let's run this. And we can see in our print statements, the first statement prints out the data as we initialized it. And then after our changes where we've substituted crunch for a and added hello with the append command, we now have a different list. We've modified it. It's been mutated. And then we can see in the last print statement that we can access the first and last variables using our indexes. So we have this mutable list. We can change data whenever we want. That can be handy. Now let's look at a tuple. So this is also indexed, but it's immutable. And the difference between the syntax for creating a tuple and a list is that the list is created with the square brackets, the tuple with the parentheses. And we have the same data. We can use, again, different types for the elements of the tuple. Yeah, we print it. I've got these commented out, append hello, and substitute the second element with crunch. And the reason that they're commented out is because they will cause errors. And we can take a look at running that and see what that looks like. Once we have set a tuple, we cannot change it. And that could work against us if we're trying to do some dynamic work. That can work in our favor if we need that data to remain unchanged. So again, just like with our list, we can print out the index values of the tuples. The only thing that we can't do with it is change it. So let's run this code for the tuple. And we could see that we get our printed tuple. Looks a lot like a list, but it's surrounded by parentheses instead of square brackets. And we're able to access our elements because it's indexed just like a list. If we were to uncomment these items that I told you would cause an error, we can run that and see what that looks like. And sure enough, tuple object has no attribute append. If I comment that out and run it, we can see tuple object does not support item assignment. So these are all of the things that we've talked about, ways that you would try to modify it, but you won't be able to. And we're back to a running code. Let's take a look now at side effects. What is a side effect? We can demonstrate that by creating a function, defining this function mutate list, where we pass in a list and then we append a value to it. So, so what's happening is we're creating a function where there's a different scope and we're passing in an object reference and modifying it. And what that's doing is it's changing in this function scope, it's changing the value of an object that is in the global scope. And that's a side effect because that's a more difficult to keep track of where one or more functions have been called and modified your data. So if we run this, we're not going to see any errors. But what we can see is that our list is now different after calling that function. We're in the main scope here, and my list is defined as 1, 2, 3. Within that scope, we've called the function which has mutated our data. And that function could, here in this example, it lives pretty close to the code where we created my list. So not really so hard to debug. But if this function lived in a module, in a package that you've imported, and it was modifying your list, that could take a little more work if you suddenly saw your list change in a way you didn't expect and you needed to figure out why. And that's a side effect because it happened off to the side and it lives on in the scope that you created the list in. So to keep our data consistent and keep it easier to debug, prevent side effects, you want to think about mutability when you're designing your code and creating data structures that are going to manage data.